Hello and welcome to this SOFiSTiK tutorial. In this video, I want to show you how to create and use a hexagon column, as you can see it in this picture, for the SOFiSTiK Bridge Infrastructure Modeler, specifically for the Substructure command. So you can see that this is one volumetric element, which is created along a divided path. You can see it right here that this form is actually not that easy, but actually once we created this outer form, we divided the path and we connected the path edges or corners. We can use a simple sweep to create the volume in between. But additionally, and this is the strong point of the SOFiSTiK Bridge Infrastructure Modeler, we want it to be parametrized and be directly user accessible, not through the family, but through the interface of the bridge modeler via Substructure. What is necessary to do that? We need to first up create parameters. These parameters, as you can see on the right side, are on the one hand user accessible, and then we have a couple of others that are defined by a formula, meaning that they will not show up in the interface of the bridge modeler in Substructure. You can see over here that we use instance parameters for the height, as well as for the width of every instance of our column over here. You can see as well that the numbers actually add up from the height. This is because all of them are defined from the reference plane all the way on the top, meaning the first bottom height is 150. Then we have plus 450 with 600 and so on and so forth. We can of course also make them dependent on each other, but in this case I chose the more clear way to explain it. But one thing that we always have to keep in mind is the coordinate system of our reference geometry. So I recommend you take a quick screenshot if you want to click along in this video, but I will switch right to Revit to show you from scratch what this process looks like. Alright, so here we are in Revit. What is now necessary to create your own substructure family? First up, we want to create a new family. In here, we now select the metric generic model adaptive. Now this three-dimensional space opens up, and right here on the top you have the view cube. With this view cube, we can align our family alignment or the family itself. And we always want to work from left to right. The way you have to imagine it later on, if the bridge modeler creates an axis, it always goes from the starting point from left to right. So basically always following this direction. Just keep that in mind. All right, what we want to create right now, before we get started with the whole family building process, we want to create our reference point. Our reference point can be started with a normal point. You can see that I already selected some reference plane right here. And I want to align this one to be completely centered to the center of my geometry. Keep in mind, you can use the align command to move this point very quickly. And we want to make this one adaptive. What does the adaptive property, you can also see it over here, now it changed from reference point to placement point adaptive, mean this is now the reference for our axis where this family is going to be placed at, meaning the insertion point of our geometry. Now we want to work in a new work plane. Keep in mind the work plane always is the reference for the new point or the new references that we want to create. What does that mean? This means if I now create another point in here, for example, right at the center of this placement point, I can now select it. By the way, keep in mind down here, Revit always shows you what we are working with right now. And if we use the tab key on our keyboard, we can select the multiple instances of elements that lay over each other. So I want to give this one an offset right now. What is an offset? The offset can be defined as a distance from a certain reference plane. Keep in mind, we selected the active reference plane. We can also show it over here. We selected this plane, meaning that the offset is now orthogonal to it. Keep this in mind, this is very important, because we will use this later on to get some parametrization going on. Because as you can see over here, I can also set it as a family parameter instead of just a simple value. The same is true, by the way, for rotations. Okay, we now want to work in the plane of this point over here. Just to make it a little bit more visible, I will turn on the reference planes of this point. I will now select a new work plane for us, which is going to be this horizontal plane of this point now. And I want to create a circle on it. So the circle in this definition requires us to select a center point and a diameter. You can see over here that the program automatically suggests to create a dimension for it. We can of course also do this later on, but this is required for parametrizing this circle over here. Okay, next up, we want to select the circle line itself and set it to a reference line. Why do we want to do that? We want to do that for it to still be referenceable for volumes that we can create with the from form or create form command, but the line itself will not be part of the volumetric element later on once it's loaded into Revit itself. So outside of the family creation. You can see it changed to green. Next up, another option that we have is to use this reference or this line to create a path. What is a path? A path lets us set a rule, in this case to create a division, a fixed division with the number of 6. And you can see over here the split geometry. Keep in mind, down here you will see with the tab we still have the reference line and the divided path separately. They are depending on each other though. But this is already what we want to use to create our hexagon reference. We will do this parametrically with point elements, and we will select the I actually didn't hit this one. I will come back to this one later, but we will select our 6 points over here. And this one I will get rid of. Why did I do this? Because if I now come into here and I would assign a proper length to this one, we could now change the width. I will show this once we created our reference geometry. Now I will always only select 2 points and create a spline in between them, meaning a straight line. This allows me to have an updatable geometry with those point references that I can simply select by dragging from the left to the right with a selection box, because this way the program will only select the points, and click on spline. Here we now have our reference geometry. So again, this line, or again tab, this reference line will not be used to create any kind of geometry in this case, because we will use this line references, which means that we also want to create them as reference lines. Next up, I want to talk very quickly about parametrization. Revit parameters can be found in the family type settings. And in here, I will just start by creating one new parameter. You can find it down here. This option will allow you to select what kind of parameter we want to create. Again, we want to create instance parameters for this type of family. And the first thing I want to create is my width for my first point. It will be created as a dimension. Its data type is a length. You can create all kind of data type properties. You can see that's in the dropdown. Let's click on OK. I want to set my first width to 1500 millimeters. I click on OK and the parameter is now added to this family, which means that now we only need to assign it to a reference. For example, again, keep in mind, use the tab key to select the reference line, that we can now change this diameter assignment. First up, we could manually change it, but I want to go up here in the label dimension settings, where we also have the option to create a new parameter, but I think it's clearer to do this in the properties of the family. And in the drop-down, we now have our width number 1 available. And you can see, as soon as I select it, the geometry is updated, or the reference geometry is updated. I can also come back, change this value to something else like 3000, click on apply, and we can instantly see the change. All right, so let's take a quick look back at the parameters we want to create. We also see the height 1, height 2, height 3, height 4. But the first one we want to create is height 1 with 0, meaning the typical offset. We will create this parameter, select height 1, instance parameter, and this one is set to 0, which is fine by me. Before we continue assigning this parameter to this point over here, I want you to select everything that we created over here, and we want to copy it into the clipboard. You will see in a minute why we want to do that. It will just take a lot of work from us by creating this family. So keep in mind, copy this point. Now we are ready to select this original point and assign the offset parameter for height number 1. I click on OK, and you can see that the program assigns it to our original reference, not reference point, give me a second, with the tab I can select it, placement point. Why did I tell you to copy this geometry or this reference geometry? Because now we can very quickly create the rest of the family, as it also is a hexagonal reference, with the paste command. Here we can assign it aligned to the same place or to a selected level. As our reference point, our adaptive insertion point, is reference to the reference plane, we can use multiples. We can pick a plane where I could select this plane over here, or I can simply, I will just go back once, I can simply tell the program align to selected levels and also select this reference plane. Keep in mind, not the reference point is our reference, but the reference plane, this one over here. So if we were to have horizontal movements parametrized, we would need to reassign this point. How can this be done? We can come into here, pick selected reference placement of our insertion point, and now it's fixed to this point, to this one actually. So this is our main insertion point. By the way, if it happens to you that the plane of this reference point is in the way because it overlays with another one, we can just turn it off, and now only the planes of our placement points are visible. All right, so next up is the height number 2 for our parameters over here, and I will just very quickly use the duplicate tab, and it recommends already height 2, which is set to 150. I want to do the same for my width number 2, which is also already recommended width 2. And this one we want to set to 1400. Click on OK, these parameters are now available, and we can just reassign it with width number 2. We can instantly see the change, and we want the height be defined by this reference point, which I actually want to unselect and now copy again, so I don't have to click this all the time. And I select this point and tell it to be at height 2. So when we take a look at the side, we can see, aha, this is now going to the top instead of the bottom. Why is that? Because the reference plane, which is used to define everything that we have in here, has its positive direction in X, Y, and Z direction in this direction, and this direction. So to the top is positive. What do we have to do for this point to automatically, from a positive input, create a negative value? We have to create a formula. We do this with another parameter. In this case, I will just have short naming, which is n for negative, and then height, underline 2, height underline 2, instance parameters, and just for a cleaner look, I like to schedule them under other. It's also going to be a length, and here we now have it. And everything that you need to do is select the parameter name. I copy it, paste it in here, and place a minus in front of it. You can see it automatically assigns the negative value. Click on OK. And right now I can once again select my point and reassign not the h2 variable or parameter. I want to have the negative one. Here we go. And now this way we keep inserting the rest of the parameters, copy our geometry, and reassign them. So once again, I come into here and I will just keep copying these parameters and assign the corresponding length to it. So in this case, it's now 600, 1200, and the last one is 5000. Go. Next up, for the width, we also want to go up to width number 5. And this one is 1500, 1400, 1100. Then we also have, okay. So keep in mind, when we take a closer look at this column over here, that we have a jump. I declared this jump as width number 2.1 because as for the height, we use for both elements or for both references the same height but different widths. So keep in mind we need a width number 2.1 as well. So I will come into here, copy this one, and this is going to be my 2.1. Which means that this one now can be assigned to 1100. 600, 400, and 400. Keep in mind, we do need negative values for all these positive inputs as well, meaning that I will just keep copying this up to 5, but I can simply change the name with H2 to H3, H4, and H5. And now my parametrization for as far as it goes for parameters is already done. Keep in mind, if this value or this parameter is defined by a formula, it's not user accessible via Substructure. But if it's defined via a value over here, it's directly accessible by the user. So let's actually get our family going. We will keep pasting these references that we already created, and keep in mind at width or at height number 2 we want to have a jump in there, meaning that we change this one to width 2.1, but the offset from our reference plane is still h number 2 or negative h number 2. And now the program will complain because 2 reference points will be placed in the same level. This is fine by us because we have the references defined properly in this case. So 2 reference points in the same XYZ plane are not an issue. So let's keep going. This is now number 3 and also H3 or negative H3. We keep going and select width 4 and so on. Once we created all the references that we want to use for creating our volumes, we can now select them. So again, we are gonna select the references for the hexagon. And we only select 2 of them because it's a very simple geometry, just from here to here. We want it variable on top and bottom. If we click on form, it's gonna create a simple sweep. Next, I want to again select my inner references, click on create form, and just keep going to the top the same way. Pay attention, we do not have to connect the 2 on the same height. We just select the outer ones again and click on create form. And this is all that is necessary to create a substructure for SOFiSTiK Bridge and Infrastructure Modeler in a parametric way. Let's create a new project and try out this family. I will just use the normal construction template and create a new project, move into 3D, and use the SOFiSTiK Bridge and Infrastructure Modeler to create one of our standard axes. Just a very quick way for you to see what's happening. Here we have the axis, and when I click on Substructure, the family will not be there automatically. Why is that? Because the SOFiSTiK Bridge and Infrastructure Modeler comes with a preset collection of families. So I will just click on process immediately for you to see what's happening here. So those are our standard families that are created the same way as I just showed you. You can also change where they are loaded from in the settings of this tool. So you can see here, load families on demand. This is also why the first click on Substructure takes a little longer. But if I were to simply load this family, by the way, if you want to have a proper name, it makes sense to give it a name when we save it. For example, Hex Column. Save it on my desktop and load it into my project. This family is directly accessible via the Substructure command, as you can see over here. And you can see all the values that we have preset over here are also available and interchangeable. Now I could, for example, also set them first up on my standard placements, but I could, of course, also create intermediate placements. This was not that smart, but let's do it like this, where I can have multiple placements as well. And I can, of course, always come back and also change settings about this family. So for example, I could give it an offset in the X direction or Y direction. Let's actually set this. I am not sure what are the presets. Yeah, presets is millimeters. So it will be a little bit more effective if I do something like this. And everything is parametrically adjustable through the Bridge Modeler.